10, 9, 8,
7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe, a daring mission to shed light on the mysteries of our closest star, the Sun.
It's going to be wonderful to see the crowds come back.
Maximum aerodynamic pressure.
And this
Every mission has its own personality and challenges to overcome. This mission in particular, the Sun, gives a new element. So there's a couple things to keep to take into consideration. The vehicle's trajectory is going very close to the Van Allen belt, and so the engineers had to create some rad tolerant electronics mass, keeping the vehicle as light as possible so that it could have the most performance is certainly a goal. And then I'm also told that this is the first third stage on a Delta IV Heavy, so those are definitely some unique aspects of this mission.
And visual cue there of separation.
Third stage telemetry. Third stage, seeing chamber pressures, seeing some periodic dropouts of telemetry.
Launch of Parker Solar Probe is just the first step. Let's talk about what it's going to do on its own in space. Did you know our models for predicting what our star is going to do are incomplete? We can't fully understand the Sun's physics if we've never been there. Here's how Parker plans to change the game. First, it's going to get up close and personal, flying just 4 million miles away from the Sun's surface. And that may not sound so close to you, but if we put Earth and the Sun on either side of a football field, Parker is going to tuck and run all the way to the 4-yard line, where temperatures can reach 1,000,000 degrees Fahrenheit. But don't worry, Parker's equipped to handle those kinds of temperatures, and it will use just a single gallon of ordinary water to do it. If you can believe it, the spacecraft's thermal regulation system is designed to collect and dissipate heat just like a car radiator. That way, we can stay where the action is, orbiting the Sun's corona in order to figure out why it's even hotter than the surface itself. But the corona isn't just harmful to our probe, it's dangerous for us as well. That's because of a little something called the solar wind, discovered by none other than our spacecraft's namesake, heliophysicist Eugene Parker. The solar wind spews harmful solar particles way beyond Pluto, and no one knows exactly what accelerates it so far, so fast. That's why Parker is designed to hang out near the origin of this wind, so we can finally figure out what it's doing and what it could potentially do to Earth.
Thanks, Jessica. Data collected by Parker Solar Probe will provide an unprecedented picture of the sun.
A lot of the instruments are very similar to ones that have flown before, but they are in very challenging environment. You know, for example, we have flown radio wave antennas on many missions, but not when they're going into 3 million degree material. We also have an instrument on the front of the spacecraft. I always refer to it as the bravest instrument because it takes no shielding, no protection from our amazing heat shield. It peeps out around the side. It's a simple instrument. It's a Faraday cup, which have flown on many NASA missions. But now we're asking it to work in this incredible environment. And so it is made with very exotic materials. And even though it's a simple instrument, boy, was that a challenging thing to get achieved.
Mick, can you talk about COLAs?
Yeah, your reference to COLAs, or collision avoidance analysis, which is performed by the United States Air Force for public safety and the rocket safety, actually. One of the considerations they analyze is objects in space. For example, other satellites around the Earth that could be in the flight path of the Delta IV Heavy this morning,